wonderful to see so many shiny faces out there. I'm not a smart man, but I see 5 people. One of them works for me, so he doesn't count. No. So today, for those of you that are interested, we're going to talk a little bit about automation, okay? Just to give you a little bit of background, when I started in this industry, I was young and looked like that, and now I look like this, and it is what it is. The industry gets to us all, right? In all reality, I grew up in the world of mold making. Okay, my family owned an injection mold making company here in Elk Grove Village for 36 years. We sold that business about 23 years ago now, something like that. I decided to go into the software rat race, bring my knowledge to that, okay? Along that road, I gave back to industry. I was teaching at local colleges for a while, teaching engineering, teaching programming, until my regular job just took too much of my time, okay? What I want to focus today on is automation, okay? And I want to focus on the idea that every company is based on a foundation of knowledge, right? They're based on a foundation of knowledge and the belief that they can deliver a better product, right? That we can build a better mousetrap than our competitors. And we're going to talk about that knowledge a little bit in depth. So, at the end of this conversation, I want you guys to kind of agree with me that knowledge makes everything possible. Without it, we can't grow our businesses, we can't better ourselves, better our professional careers. So, knowledge, it makes up the process you follow, the pricing you use, it makes up everything. The suppliers you work with and trust. Everything comes from the knowledge you have built over time. The knowledge your bosses have built over time. This is where it all comes from. Speaking of process, let's talk about process for a minute. Let's say you get a new job. Okay, and here we're talking about mold, so we're going to talk about the process of manufacturing a mold. When the mold comes in, you start with the design. That's where every mold starts, is with the design. You're going to start by having a preliminary design. You're going to review that preliminary design with your customer. Your customer then is going to revise it, because that's what customers do. They can't make up their minds from day 1 to day 2. We all know this. That revision process goes back to a review, and then goes back to a revision process, goes back to a review, and this runs in a circle for a while until everyone agrees that the design is ready to use. At that point, you get to deliver a design. Where is that design being delivered? It's being delivered to whoever is manufacturing this mold. It could be your own internal organization. Maybe you are doing this with an external manufacturer, who knows? But in that manufacturing process, and I'm not going to hit all of the points of manufacturing a mold, just big ones, you're starting with ordering materials, ordering your consumables, right? You are going to prep everything you possibly can prep for heat treat, get it out to heat treat. You're going to bring that back in, you're going to start finished machining, you're going to assemble everything, and then God willing, you're going to deliver, right? And at the end is a payday. At least that's what we all hope for. We get paid. Now, in reality, what happens in that process when there's a breakdown, okay, when something falls apart? And that's really why we want to talk about automation, because we want to stop simple elements from causing hiccups in that process of start to finish mold making. Right? So let's take another look at this process a little bit. Again, we're in this design, right? Let's maybe break down the preliminary aspects and what do we do when we're doing a preliminary mold design? We start with prepping the part. I don't care who you are. You import data from your client. That data either imports cleanly or it doesn't. You then have to fix the data, or you're checking it, make sure there's proper draft angles on it, it's ready for moldability. You have to make modifications, whatever. This is your preliminary part setup. After that, you begin developing your core cavity blocks, right? You do the split, you develop the inserts, the sub-inserts, the action inserts, everything that makes up the meat and potatoes of that mold. Once that's done, then the mold design can actually begin. Now, what do I mean by mold design? I mean the full-on mold design. We're talking your mold bases, your ejector pins, your water lines, everything that goes around the mold to make the mold function. That's where we're going to look with automation today, okay? So if we take a look at mold design, we break it into a couple of key areas. You have mold-based design, you have injection portion of the design, you have the action items, the injection side, the water lines, so on. If you look at each of those objects, each of those individual items have their own idiosyncrasies that you have to follow, right? So in the mold base, we have to design plate work. With the plate work comes componentry, screws, pins, bushings, things like that. Each of those pins and bushings come with the manufacturing process that's associated with them, right? So all those little things have little idiosyncrasies of their own to deal with. And this is where designs can break down some. Because you'll have designer A that believes they should put this type of clearance on this component, and designer B puts this type of clearance on this component, which just leads to the manufacturers on the floor that have to build it, leaves them with their hands up in the air not knowing which is the right numbers they should work to, right? And at the end of the day, both designers are right, because it's just clearance. What happens now when we enter the world of automation? So now we're going to talk about automation a little bit, and the how it works and the why it works, and why you want to be using something that is possible of automation in your everyday mold design life. Automation should be used to minimize mistakes, right? Or completely remove them. And I'm going to give you some samples here in a few minutes to help you understand what I'm talking about. It should speed up a given process, minimally, okay? It should remove personal opinions. And yes, I'm saying that every engineer has personal opinions. Every engineering manager has the ultimate opinion. And I'm not picking on any of you guys to be mean. We all have our opinions. But at the end of the day, whose opinion matters? The company. You should be following the company's opinion of how this should be done, period. And focus your engineering talents on the hard aspects of the design, okay? The other thing that's interesting about automation is it ensures stability and predictability. Because if we know these rules are being maintained, we can predict better when we're quoting jobs, right? Cool. So automation works by capturing company knowledge. There's that word again, right? We have a way of doing something, so we want to capture that and make it reusable. It could be as simple as how an item is positioned in the mold, okay? When I put my stop pins in, I want them positioned like this and this from here, period. That's the way we do it. And moving forward, that's the way we're always going to do it. When clearances are used and so on. It should be made easy to use and deploy. If it's not easy to use and deploy, are your engineers and your employees going to use it? No. They're going to fight you on it. Okay? Now, let's talk about other items that help in automation. Libraries. I'm sure we all have libraries of things we use in our everyday engineering. For example, here I'm just showing a bunch of libraries of materials. I've gone through in my samples and I said, okay, I use material A, material B, material C, it can be H13, S7, whatever. I have it set with all the properties that we always document, and it's done once and forever. I have the suppliers I order from automatically listed in there, so when I build my bill of material, everything's done, and it's perfect every single time, okay? The same thing can be done with standard mechanical libraries, okay? Here you see screws and bolts and fasteners, things that we take for granted, but yet many of the applications out there make you work too hard to use. We'll talk about screws in depth here in a minute. Then you have libraries linked to a given supplier, and here I think I'm using DME. Could be Hasco, PCS, Progressive, Sumi, whoever you guys use. But you want to have access to these components, and more importantly, to the components' manufacturing processes that are associated with them. We're going to talk about that here in a second as well. So, how many of us have seen this before? Silly question, right? It's not going to cap screw. It is the basic building block of the mechanical world. How many of us have designed something in the past where we had to type in the clearances for the standard clearance hole, the tap hole diameter, everything, because you had to document this for manufacturing. And this is silly because when's the last time a quarter 20 changed? Or half 13? It hasn't. It's a standard for a reason. So why is it that everyone insists on taking the time of typing this stuff in manually? All that does is add to the time. What you really want to be doing is thinking about what clearances your company wants to work to. Okay, you can use the standard ANSI or ISO or DIN or AFNOR clearances, or maybe you have your own strategy on how you need to manufacture these things. But set it, forget it, move on. And when you set it and forget it, make sure it's using values that the downstream manufacturing people can actually use. Okay? Don't round values on the engineering side thinking, oh, the guys on the floor, they know what I mean. They may know what you mean, but their automated software sure as hell won't. Right? So let's have a look. So in this video, I'm going to show you adding a screw with no automation. Okay? And it's pretty exciting. You're going to see what engineers do today in most engineering environments. If they have access to a library, they're finding their component, They include it in their assembly, and now they're going to start positioning it. And this is super duper exciting, right? It's not. We've all seen this type of work before. At the end of the day, what's happening is, you can see, positioning is happening. I'm orienting my screw. I'm going to select the correct length for this. Okay? This process is going to take about 3 minutes. It's a good thing you guys are sitting because it's extremely boring to watch. At the end of the day, once this is positioned, that's great for the component, so that'll update our bill of material, but now we have to go and modify each and every plate that screw passes through. Okay? Depending on the software you're using, you have to maybe remember what the right counterbore hole diameter is for that size screw. And you have to remember what the right clearance hole is, what the right tap diameter is, and so forth and so on. And here you can see, it's exactly what I'm showing. It's a manual process. This is one screw in a design. How many screws go into a typical mold design? 2? 400? It's quite a big number, right? And so if we take a look at what I wrote down here, it's 3 minutes to do this process for an experienced user. That's a long time to add a screw. Now, let's look at it using automation. So if you use automation and you capture your manufacturing process in it, your user should be able to more quickly locate and identify the screw. So here, I'm positioning it right off the center of my cavity lock, off the back face of the plate there. I select the face I want to attach it to. The software automatically picked the right length. I click OK. The clearance holes are in, the drillings are done. It took 20 seconds. I'm not a smart man, but 20 seconds seems faster than 3 minutes, right? Let's take it to the next level. What about making a change? Because again, remember those changes? Engineering manager comes in, the customer comes in, whatever. You know, Bill, why did you use this size screw? I don't know, it seemed good. So you have to change it. In a non-automated environment, okay, you're gonna go make that change. It takes 1 minute and 18 seconds to go pick the new library component and then go manually update the correct drilling sizes. And this is a good use of an engineer's time, right? Again, we're just dealing with socket and cap screws here. It is not exciting. Nobody wants to be a designer to put socket and cap screws into a design. So, let's look at the automation side. You can see the increase right there. It's 11 seconds. All I'm going to do here is come in and choose the different diameter I want. The automation is capturing, because it already knows the thickness of the plate, it knows everything. It has everything it needs. All it has to do is change the sizes and the clearances and the drillings. 11 seconds, a little bit faster. Again, let's talk about the reality of mold design now. So, in an automated world, 20 seconds to include a screw versus 180 seconds. Okay? If we take 100 screws in a given design, you have 2,000 seconds or 33 minutes worth of work using automation against 18,000 seconds or approximately 5 hours of engineering time on screws alone. Nobody wants to think of this when they're thinking about coding mold design. They don't want to think my engineers are wasting 5 hours putting screws into the design. But guess what? It's the reality when you are not using an automated platform. Okay? And again, carry it downstream. When you're in an automated world, chances of mistakes being made are very slim, next to no mistakes. When you're in a non-automated world, mistakes are possible, right? Because we're human, and we can fat finger numbers with the best of them. Carry it forward into downstream automation for machining. If the numbers are correct in engineering, the numbers are correct in machining. No problems. If the numbers are wrong in engineering, the numbers are wrong in machining, that's a costly problem. Okay? And again, the amount of time it takes to change, 10 seconds versus 78 seconds for single components. Clearly, automation wins. Now, let's talk about that downstream automation side. And again, here, I pick on our clients all the time. When they send us files, they send it to our support system. I pick on them all the time for being lazy with the clearances they enter. On our diameter here, we're going to say that's that size. We're adding 60 thousandths to it. The result is 0.6225. Is there a standard drill for that? No. So when you run automated drilling in any CAM software that's looking for that diameter drill, it's going to fail. And it's because the engineer meant a 16th, but they just typed those 60 because the guys on the floor, they know. They understand what we're saying. Okay? It's a very old school way of thinking. So, what happens if we actually take the half a second to add the missing 2 digits? You have a real number at the end. The downstream automation works. And it takes no more effort to do this. You just have to care to type in the real value, okay? Every software out there lets you do math with it. That's what they are, the big visual calculators. If you don't want to type the decimal in, type the fraction. That way you get the real math, and then math works. Now, I have one more sample for you. We've all seen ejector pins, right? So a side of the cap screw, there's not a lot going on in that. There's a couple of drillings you got to do. On an ejector pin, however, there's like 8 to 12 different things going on. You got different clearances through all the plates. You have to trim that pin to the molding detail. You have to key the pin if it's needed to key it, right? You have to put in the correct line travel. You have clearances on this plate, down on here, down on here. You can see everywhere I'm pointing is another area where an engineer would have to make a decision. And depending on the number of plates you're passing through, that may increase. In an automated world, let's see what the possibility can be. So, in this sample, what I'm doing is I'm going to include ejector pins into this design, okay? When I include the ejector pins into the design, I'm doing it in a logical way. When you're thinking as a mold designer, okay, it's time to put in my ejection, the first thing every mold designer does, they want to plan view and they start drawing 2D circles. Why? Because 2D circles are efficient. It's fast. What's up, big guy? It's fast. You can identify very quickly where you need to put things. Once the 2D circles are in, you constrain them. You have a meeting about them. You all shake hands, high five, do whatever it is your company does to sign off on the process that is your ejection. And then at the end of the day, we'll see what automation does. So here real quick, again, just to show off a couple of fun things. Here were some geometric rules. Again, you still are going to be a designer. You still want to say, okay, I'm worried about these ribs, they're going to stick, so I'm going to center a pin right there. I'm going to add some dimensions here. I'm going to make sure I type in real values, because then it's really documentable. Okay, is that a word, documentable? Anyway, so off we go. I think this goes on for just another second or two. And then we're going to go ahead and get the ejector pins in. At the end of the day, I think this is what makes the process simple. Remember at the beginning of my slides where I said you have to keep it easy? Anyone can draw a circle. This is easy to wrap your heads around. Not anyone can insert complex 3D components. Joe has a problem with circles, sometimes. All right, here we go. Here's our last set of circles. Lovely. All right, so once that's constrained, we're going to validate your sketch. Actually, I changed my mind. I'm going to put one more in right here. Give a nice big 3D detail right there. The other thing automation should do for you when it comes to ejection is, I talked about keying, right? The system should be smart enough to look at the geometry. Here we go. Here comes the pins. Boom. And it should trim the pin automatically to the 3D details. It should automatically determine if they need to be keyed, right? So this process, we're putting 11 pins in, this process should happen instantly and effortlessly. This is why automation exists. When we click OK, the next thing it's going to do is put all of these drillings in. And again, it's using our company knowledge. Once that's done, you're done. Now, what's interesting here, it took, this video is about 2 minutes and 33 seconds long, or 14 seconds a pin. It's 11 pins. Imagine a mold design that has 300 pins. If you're doing it pin by pin, I bet you it takes longer than this, right? And at the end of the day, again, is putting ejector pins in the exciting part of mold design? No. It's another component that has to be dealt with. And that's the idea. This is really what I want to come across with automation. There are many things that can be automated in the world of mold design, whether it's standard components from standard suppliers to your own processes. Many of our customers around the world, they have their own ways of doing side actions or lifter assemblies or mold straps or whatever. They have their company standard. They take the time, teach it to their software, our software in this case, capture the manufacturing process that goes with it, maybe it's a pocket, some drilling, some clearances, some whatever, so that it takes seconds to include those objects. Not half a day, not all day. Let your designers work on the things that matter. That's it, that's all I got to say. Does this make sense to everybody? Is everyone using an automated process today? Should be if you're not. If you're not, you should come visit us at Do Us 543. I gotta plug us somehow. Now, I know this is a friendly conversation, so I'm not supposed to say who I work for. So we'll just see if you guys can figure that out. All right. Anyways, thank you again for your attention, and my bad jokes are bad, they don't get better. In all reality, do you guys have any questions on automation or ways it can be used in your world? I'm happy to answer them. If you want me to answer them here, come visit me at the booth, I'll answer them there. Okay? All right, thanks everyone.